All right, let's jump right in. We're going to tackle one of the absolute biggest questions in AI today. How can you tell if a machine is actually learning something or if it's just getting really, really good at memorizing? Believe me, it's a huge difference, and getting it right is the secret to building AI that actually works in the real world.
I mean, this is the core of the problem, right? An AI that just memorizes things is pretty much useless when it sees something new. So how do we build one that can truly understand and, generalize from what it's learned? Well, you might be surprised. The solution is actually way more intuitive than you'd think.
So to get our heads around this, we're going to use a classic analogy that everyone, and I mean everyone, understands: a student cramming for a big exam. And believe it or not, this super simple idea is the foundation for how we test even the most mind-bendingly complex AI models today.
Okay, so just picture a student. They've got one single textbook for their entire class. They spend weeks with it, highlighting stuff, rereading chapters, doing all the practice questions at the end. This is their learning phase. They're just soaking up everything from that one single source.
Now, if you ask this student any question that's pulled word for word from that textbook, they'll ace it. No problem. They've memorized the answers perfectly. But here's the real question. Is that genuine understanding, or is it just really, really good memorization? The true test, well, that's still to come.
Because, when exam day finally rolls around, the professor isn't just going to copy and paste questions from the book. Nope. The final exam is going to have new problems, questions that force the student to apply the concepts to situations they've never seen before. This is the moment of truth.
And here's the brilliant part. This exact same principle, study from the textbook, then get tested on totally new material. That is precisely how developers figure out if their machine learning models have actually learned a thing.
So let's see how this maps directly onto the machine's world. It's a perfect one-to-one match. The student, that's our machine learning model. The textbook they study from, that's what developers call training data. And that final exam with all the brand new questions, you guessed it, that's the testing data. Simple as that.
So you might be wondering, where do developers get this textbook and this final exam? Well, they don't go out and find two different sets of information. They do something much cleverer. They take one giant data set and just split it. And this simple act of splitting data is one of the most fundamental steps in all of machine learning.
So let's be super clear here. The training set, that is the textbook. It's the data the model gets to study and learn all the patterns from. The testing set, on the other hand, is the final exam. It's new data that's been held back, kept completely separate, just to evaluate the model later on.
A really common way to do this is with what's called the 80-20 split. It's pretty straightforward. Developers take a big chunk, say 80% of their data, and that becomes the textbook for the model to train on. The other 20%, that gets locked away in a vault. That's the final exam, and the model never, ever gets to see it while it's studying.
Now, this might sound like it's complicated to set up, but honestly, with modern programming libraries and tools, it's become incredibly simple. In fact, it often takes just a single line of code to do this whole thing.
And here it is. For anyone who's played around with Python, this probably looks pretty familiar. The command is train test split. And the most important part is right there at the end, test size equals 0.2. That's literally just telling the program, hey, hold back exactly 20% of my data for the test. With just that one little command, the textbook and the final exam are created, just like that.
Okay, so the data has been split. The model has studied its textbook. Now it is exam time. This is where we find out if all that training actually led to real, genuine learning. The process is a really clear three-step exam. Step 1, the model trains on that big 80% textbook data. Step 2, we unleash that hidden 20%, the exam data, and ask the model to make its predictions. And finally, Step 3, we grade its paper. We compare its predictions to the actual answers to get an accuracy score, and that score is its final grade.
If you take away just one single thing from all this, please let it be this. This is the golden rule of machine learning. Always, always test your model on new, unseen data. It is the only way you can be confident that your model has truly learned something and hasn't just memorized the homework.
And that, of course, leads us to a final, really interesting question. We've talked all about how important it is to have a fair test, but what happens if the test itself, that 20% of data, wasn't actually a good snapshot of the real world? This is where things start to get a lot more complex, and it hints at some of the deeper challenges in AI. But for now, you absolutely understand the fundamental difference between training and testing, the difference between just memorizing and truly learning.